Hey guys, welcome back to my channel. Today in this video I am going to talk about the very basic data structure concept, and that data structure is array. So array is very fundamental data structure in computer science, which is really important to understand, which helps us to solve lots of problems in the data structure and algorithms. So first let's start with the definition of the array data structure. So let's first talk about what is an array. So array is basically collection of the same type of data stored at continuous memory location. So let's see, for example, this is the memory and each box is 1 byte. So consider each box as 1 byte. So these are different multiple bytes within the memory. So for example, if you want to store integer data in the array, so how memory will get allocated? So memory will be like this. For example, we have stored integer value within an array. For example, array at 0 is equal to 1 we have stored. So integer value, how much memory it allocates? It allocates 4 bytes of memory within the memory. So how it will get allocated here? So each box is 1 byte of memory. So one integer contains 4 bytes, so it will allocate 4 bytes of memory here. So this whole 4 box will get allocated to the integer value within the memory. So that's how memory gets allocated, and it will always in the continuous manner. So let's understand how memory let's understand what is this continuous memory allocation means. Continuous memory allocation means, for example, if we have declared an array of size 3, array of size 3 means we are going to store 3 elements within the array. So for example, we have stored 1, 2 and 3 different integer values in the array. So how memory will get allocated? So suppose base address we are taking as 100. Each integer will take 4 bytes of memory. So each box will get 1, 2, 3, 4. So for 4 boxes are getting allocated. So the next integer, from where it will get allocated? From 104. Why? Because base address is 100 and each integer is going to take 4 bytes of memory. So next integer value will start from 104. So this 100 value I have taken as a base address, and this is not actual memory location. It is saying for assumption and to explain you, I have taken 100 as a base value, but in actual it contains some random value. So here I have considered 100 as a base value. So next memory element will get allocated at 104 memory location, and once here again it will take 4 spaces, 1, 2, 3, 4 boxes, because each box is of 1 byte. So 2 has taken 4. So next, what will be the memory location? Next memory location will start from 108, because from 104 to 108 2 has taken. Next element is 3. So 3 will take from 108 till 112. So this is how in continuous manner each element will take the memory location within the memory. So this is how data in the array data structure get stored. So now another concept is how we define size, and another concept is about what will be the array size, what is index and what is value. So within an array we have two very important concepts. One is index value and another one is value which is getting stored at that particular index. So for example, if here we have created an array of size 6, n is equal to 6. What does it mean? It means there are 6 elements which will get stored within this array variable, and for each element index value will be allocated. So index value starts with the 0 and ends at n-1. So whenever we have to store any value, so it will always start with the 0th index and then first, second, third, fourth, fifth. So this is how each element will get stored at ith index within the array. So now how we will calculate the address of particular so next we will see how we can calculate the memory location of particular element. So for example, I is the index equal to 0 in starting at 0th index. So base address, for example, we have taken 100. So formula will be like base address, which is 100. Formula will be like this: base index plus how we can calculate the memory location. So to calculate it, we need two things. One is base address plus ith index into what type of data we are going to store. So here we are storing integer, so 4 bytes of memory it is going to take. So this is how we can calculate the memory location. So here we see at I equal to 0, 0th index will start from 100 memory location. I equal to 1, first index value will start from 104, second will start from 108 according to this formula. So this is how we calculate the memory location. So here I have written memory location of ith element of an array is equal to base address plus I into amount of space for one element. So it depends upon, like if we are storing integer, so 4 bytes of memory it is going to take. If we are storing character, 1 byte of memory it is going to take. So this is how different data primitive data types are there. So according to that it will allocate the space for one element. So that's how we can calculate the memory location of ith element of an array. Next is how we can read the elements within the array. So we can read randomly any value within the array, but to read it we need to use the index value. So that is why we are that is the use of index value. So for example, if we have given an array of size 3 and it stores 1, 2, 3 like this, 0, 1, 2. So how it is going to work? Like suppose we have to take array of 0th index. So passing the index value in the array variable, we can directly get 1 as a result. So we can randomly access using the index value. So what will be the time complexity to read any value within the array from the array? So time complexity will be big O of 1. At constant time complexity we can fetch any data from the array. So this is what the concept of the array. So now next I am going to explain you one basic problem. So let's see this problem. For example, given an array of element of size n, print all elements. So we have given an array of elements and we have to print each element. So how we can solve this? So it is very simple. We have to simply write the for loop to iterate each element of the array and we have to simply print it. So to print each value, what we are doing, from index 0 to n we are iterating. So according to that, the time complexity will be big O of n. Let's talk about another problem. Another problem is, for example, given an integer array of size n, count the number of elements having at least elements greater than itself. So what this problem is saying, we are given an array. So let's talk about another problem. So the problem statement is, given an integer array of size n, count the number of elements having at least one element greater than itself. So what problem is saying? Let's see, this is an example. We have an array A which contains elements. So the question is saying element at least, the question is saying what we have to, so the question is saying we need to find the count of number of elements having at least one element greater than itself. So let's see here, we have given an array A and it has multiple elements. So what question is asking, we have to find the number of elements which has at least one element greater than itself. Means suppose, for example, we are taking 2. So we have to check, is there an element, at least one element in the array which is greater than 2. But we have to exclude the 2 because 2 will be always equal to 2. So we have to exclude the 2 and remaining elements we need to check. So we will check here. Here next element is 5 which is greater than 1. So basically this one element has at least one element which is greater than itself. Similarly we will pick 5. For 5 also we will check, is there any element which is greater than, at least one element greater than 5. So we will check it. This one is 1, next is 4, next is 8. 8 is greater than 5. So 5 also we can consider. So basically 2 and 5 we are considering. Next is 1. So for 1, is there any element greater than 1? So next is 4, 5 also, 2 also, these are greater than 1. So at least 1 should be greater. So 1 also we are going to consider. Similarly next for 4. So for is there any element which is greater than 4? So yes, there is. 8 is an element which is greater than 4. So 4 also we are going to consider in the count. Next is 8. So for 8 we have to check, is there any element which is greater than 8? So I don't see any element greater than 8. So we are not going to consider 8. So we are not going to consider 8. Next is 0. So is there any element greater than 0? So yes, there are multiple elements. So we are going to consider 1 as in the count. So next is 8 again. So there is no element greater than 8. So we are not going to consider this 8. Next is 1. So for 1 also there are greater elements. So we are going to consider this 1. Next is 3. So for 3 also there are multiple greater elements. So we are considering this. So this one green. Next is 8. So for 8 there is no greater element. So we are not going to consider this element. So let's count green 1. So 1, 2, 3, 4, 5, 6, 7. So answer will be 7. So there are 7 elements which have elements greater than itself. At least one element greater than itself. So this is the output of this question. So now let's solve this problem. So whenever we solve any data structure problem, so we have to keep one thing in mind. We will never start with the optimal solution. We will always have to think the brute force solution first, and then we have to think the optimal solution. So this is how we should approach the data structure and algorithm problems. So let's think about the brute force approach to solve this problem. So how we are going to solve this problem using brute force? So here what we have seen, we have picked one element and we have checked rest of the elements with that particular element. And what we were checking, we were checking is there any element or at least one element is available which is greater than that particular element. So what we have to do, we have to first, we need a pointer I to pick that particular element, and then we need another pointer j, and once we will pick ith element, what we will do, we will iterate through whole array from j equal to 0 to n, and we will keep checking is there any element greater than a of I. So what we have to do, we have to pick a of I as an element, and then we will run another loop a of j, which will keep checking is there any element which is greater than a of I. So if at least one, if we find one element, we will do count equal to 1. So we will increment count by 1. So this is how we have to solve. So let's see here, I j pointer a of I, a of j, and we have to check a of j is greater than a of I, then we will have one more variable count which we will initialize as a 0. So I equal to 0, at a of I equal to 0 and j also starting from 0. So a of I of 0 is what? 2. So at 0th index here we have 2, so we are going to write 2. Okay, at a of j also 2. So a of I is greater than a of j is greater than a of I, so wrong, so count will remain 0. Next I will iterate j increment with 1, and next j will move here. So at a of 1, what is the element? It is 5, and a of I will remain 2. So here 2 is smaller than 5, so basically this condition is becoming true, so we will increment count by 1. Okay, we have found this element, so we will simply terminate this j and we will increment I to 1. So at a of I to 1 and j also we will start from 1. At a of I of 1, what is it? The element 5, and here also 5. So this is not going to be true, so this will remain 1. So next j will iterate, j will go to second index. At second index, j will move here. What is j? A of j is 1, so here it will be 1. So here at a of I we have 5, and here a of j which is 1, so this one is not greater than a of 5, so this is become false, so count will remain 5. So this is how, like, for each ith index we have to run the j from I to n to check each element and to find the count. So this is the brute force approach, and in brute force approach what we are going to do, for every elements of A, check if a greater element exists. So we have to iterate from 0th index till nth. So how will be the code? We will initialize count variable as 0, and next we will write for loop I equal to 0, I less than n, I plus plus, and then again we will write another loop for j equal to 0, j less than n, j plus plus. If a of j is greater than a of I, what we will do? We will increment count plus plus. So once we have found one greater element, we will break. We do not have to iterate j pointer further. So we have to break the loop, inner loop. So once we will break the inner loop, again here I will start, and then similarly for each element it will keep checking. So now this is the brute force approach. So once we get the solution for the brute force approach, what we have to do next? We have to calculate the time and space complexity. So for this problem, time complexity is, this one is going to run from 0 to n. So for this one it will be n times this loop, external loop is going to run, and internal loop also going to run n times. So basically what will be the time complexity? Time complexity will become big O of n square. Found the brute force approach. Next thing is we need to calculate the time complexity and space complexity. So here time complexity will be n square, because we have one loop which is going to run from 1 to n, and we have inner loop which is going to run from 1 to n. So this will run till n times, and this one also run till n times. So total overall time complexity will be big O of n square. And what will be the space complexity? Space complexity will be big O of 1. Next, what we have to do? We have to optimize our solution. So whatever brute force solution we have got, we have to optimize further to make it better, to make our solution better. So next what we have to do? We have to optimize it. So how we can optimize it? So after finding the brute force approach, we have to think about this optimal approach. So let's discuss about the optimal approach. In optimal approach, what we can do? So suppose in this array, within the array we have to first find the maximum element, and after finding the maximum element, so here in the array we have max element is equal to 8, and after that we will check how many elements are equal to that max element. So next what we have to do? We have to first find the max value, and then next we have to count how many elements are equal to that max value, and then we have to subtract the n minus the count, and then that will be the final result. So how our code will be? First we have to, like for example, int answer equal to int mean. So first we have considered minimum value, which will be something minus 2 to the power 31, and then next I will iterate from I equal to 0, I less than n, I plus plus, to find the max value a of I greater than answer. So it will be answer equal to a of I. So this answer is nothing but max value. So next what we will do? We have to check count how many elements are equal to that max value. So what we have to do? We have to write a loop for I equal to 0, I less than n, I plus plus. If a of I is equal to answer, we have to increment the count plus plus, and next we have to return n minus count. So this will give the final output. So what will be the time complexity? For this loop it will run for big O of n times, and for this loop it will again run for big O of n times. So overall time complexity will be big O of n plus big O of n, which is big O of n. And space complexity, because we are not creating any new array to store the value, so only constant space it will take. So space complexity will be big of 1. So this is how we can optimize the problem solution. So that's it for this video. I will come with another problem based on array in the next video. So if you like this video, click on the thumbs up and subscribe to my channel. So for now, thank you and happy learning.